Hello everyone, myself Sowmya, Assistant Professor in CSE AIML Department, MLR Institute of Technology. In this video, we are going to discuss about types of blockchain. Coming to the overview of this presentation covers what is meant by public and private blockchain, permission and permissionless blockchain, and different types of blockchain along with their features and drawbacks. So, we have divided blockchain based on the type of accessibility and permissions. Accessibility in the sense what type of data I can access, how much data I can access, and who can access. All those things are nothing but accessibility. And the permission. So what are the permissions I have? Can I read the block? Can I write the block? Can I create a block? Can I validate the block? So those are nothing but permissions. So based on these accessibility and permissions, we have divided the blockchain. So the first one, blockchains are categorized based on the user identity. So user identity, whether we can reveal the identity of the user or we need to maintain the identity as private. So based on the user identity, or we can also call it as a authentication. So whether we are authenticating the user or not. And the other factor is user rights, or it is also called as authorization. Rights in the sense what are the different roles of a user. For example, if the user is existing in the blockchain, what he can do, whether he can read a block, whether he can create a block, whether he can validate a block, all these are called as rights of a user. So based on these two factors, the blockchain is divided into two categories. The first one is public and private blockchain. It is based on the user identity, whether the user identity is public or private. And based on the user rights, it is divided into two categories, that is permissionless and permission. So whether the blockchain is permissionless blockchain or it is a permission blockchain. So coming to the public and private, the name itself, it is telling that the public blockchain is open. That means anyone can join the network. Coming to the private blockchain, it is restricted to only a specific user. So blockchain is considered to be either public or private in this public and private blockchain based on whether the network is open or accessible to anyone with an internet connection. So based on whether the network is open, whether everyone can access the network or not. So based on that, it is divided into public and private. So in the public blockchain, anyone can join the network. So as we discussed just now, the public network is nothing but anyone can join the network. So they can download a copy of the ledger, they can initiate, they can broadcast or mine the blocks. Users are anonymous. So here in the public blockchain, anyone can join the network and all the entries or all the users have the equal rights. So they can download the copy of the ledger. We know the ledger, right? So every block will maintain a ledger, data copy, right? So that can be downloaded. It is only read-only format. We cannot edit that. It is read-only format. They can download the copy and they can initiate. So if they want to initiate the transaction or if they want to mine the block, they can also do that in the public blockchain. But coming to the private blockchain, membership or association with the blockchain is restricted. So if I want to join the network, I need to be an authorized person in the private blockchain. For example, if I consider an engineering college, so simply I cannot join there, right? So I have a process for that. I need to write MCET exam. So through that MCET exam only, I can enter into that college, right? So if I am a faculty, then I need to undergo for an interview, then only I can join that network, right? So like that private blockchain in the sense, there should be some process to enter into the network. So one has to meet certain prerequisite conditions to be part of blockchain network. So in the private network or private blockchain, there have some conditions to join into the network. So users are not anonymous. So users are known users. But coming to the public network, anyone can join. So in the world, anyone can join the public network. That's why users are anonymous. So one user is not known to other user in the public blockchain. Whereas in the private blockchain, so I can consider a private blockchain for our college. So in our college, everyone, so one person can know other person also with the identity. So here based on the accessibility or the rights, we have divided the blockchain into public and private, permission and permissionless. So the next category is permissionless and permissioned blockchain. So the category is based on the type of the rights the user or the node has within the blockchain. So what are the different rights of a node? So rights in the sense whether he can read, whether he can write, whether he can mine the block. So all these are different rights of a user. So based on this, it is divided into two categories, that is permissionless and permission. So a blockchain is considered as permissionless if no such control entry exists and all the nodes have equal rights to the network. So as we discussed now, in the private network, there will be some central authority to authorize a user. So if an unknown person enters into the college, they will not allow, right? So there should be some process. So here there will be some central authority to authorize the person in the private blockchain. But in the permissionless blockchain or the public network, so we can directly enter into the network. There is no central authority to monitor this. And all the nodes or all the users have the equal rights. So they can all read, receive and send the transactions and participate in the consensus mechanism also. So each and every node has equal right. So this node can validate a transaction. This node can also validate a transaction. And these are all the nodes can do all these things. They can read, they can receive, they can send the transaction. They can also validate the transaction using the consensus mechanism. But coming to the permission blockchain, the central entity or the group restricts the roles that the nodes can play. So they will restrict a central entity or a group of persons will restrict the nodes. What are the actions can be done by the nodes? For example, in our college, if I consider the principal is the central authority, he will control the all the actions. If I want to do something, I need to take the permission. So it may be a single central authority or it may be a group. For example, if the faculty wants to take a leave, there is some order, right? So first it needs to take the permission from HOD, then he will take the permission from principal, right? There is a order. And we have some group of people here. So in the private blockchain or in the permission blockchain, there may be a single central authority or maybe a group of central authorities will be there to control the network. So these are all the four different types of categories: public and private, permission and permissionless, but almost they are similar. But in the permission and permissionless network blockchain, we are mainly focusing on the rights, whereas in the public and private blockchain, we are focusing on the authenticity of the user. So based on the authentication and authorization, if I merge all these four things, public, private and permissionless blockchain, we are dividing the blockchain as four types. The first one is public blockchain. It is also called as public permissionless blockchain. So public in the sense there is no need to take anyone's permission, right? It is also called as permissionless blockchain. And private blockchain, it is also called as private permissioned blockchain. That means if it is a private, if I want to join the network, I need to take the permission from a central authority. So that's why it is also called as private permissioned blockchain. And next is consortium blockchain. It is also called as public or private permissioned blockchain. So again, public or private, it is combining the features of public as well as private, but what it is actually permissioned blockchain only. But coming to the last one, hybrid blockchain, it is interconnected public-private blockchain. So we'll discuss all these one by one. So the first one is public blockchain. So the first public blockchain network is a Bitcoin. So we know the first application of blockchain is also Bitcoin. The first blockchain created is a public permissionless blockchain, that is Bitcoin. So what are the features of this blockchain? I mean, we know the public blockchain in the sense it is open, anyone can join. And we'll also see other features. The first one is anyone can join the networks. The name itself, it is telling that it is public. Anyone can join the network. No permission required to read or send the transaction. I don't need to take anyone's permissions to read or to issue the transaction, to transfer the transaction, to download the copy of the transaction. And the standard consensus mechanism is POW, that is proof of work. So in the previous video, we have discussed about the consensus mechanism. So as we know, it is a decentralized network. The public blockchain is a decentralized network. There is no central authority to validate the transaction. So if I want to create a transaction, someone should validate it, whether the transaction is valid, correct or not. So if it is a central authority, I will send this transaction through the central authority. He will validate. If it is a valid transaction, he will approve that. If it is not valid, then he will disapprove that. But in the decentralized network, just like public blockchain, there is no central authority to monitor this, to validate this. So what we are doing here, we are following the consensus mechanism. Consensus mechanism is nothing but agreement, right? So here we have 4 nodes. So all these 4 nodes will validate this transaction. So this node will say yes, this node will say yes, this node will also say yes, and this node is saying no. So if I check the majority of the nodes are saying yes, then the transaction is a valid transaction. So this process you are calling as consensus mechanism, and the consensus mechanism we are using in the public blockchain is a proof of work. So we know in proof of work, we are going to use some mathematical puzzle. Whoever solving that puzzle first, they are going to validate the transaction. And there is no single point of failure. So if we have a central authority or the centralized server, there is a problem with the single point of failure. But in the decentralized network, it is also distributed, right? So each and every node will maintain the ledger copy, the data copy. So if this node is failed, this data will be lost. This node is also failed, this data will be lost. But still we have 2 copies of the same data. So that's why there is no problem with the single point of failure. And high cryptographic methods are used to secure the data. So the data will be stored inside the block is in the form of cryptographic data. That will be, the data will be encrypted, and that encrypted data will be stored in the blockchain. So high cryptographic methods are used to secure the data. So the data is very secured in the blockchain. So coming to the limitations of public blockchain, low transaction speed, 10 minutes to create a block. So in a block, we have some set of transactions. To create a block, it will take 10 minutes of time. As we know, it is a older technique or the initial technique, the public blockchain, and the consensus mechanism we are using is proof of work. So in the proof of work, as we discussed in the previous video, we need to solve one mathematical puzzle. So which requires more power and more resources. So for that, it will require a high amount of energy and the computational power. And the participants with supercomputers have chance of mining. So if I want to mine that, if I want to perform the mining process, if I want to be a part in the consensus mechanism, I should have a supercomputer. Then only I can be a part of mining. So these are all the different limitations of the public blockchain. So this figure indicates the public blockchain. So it is open. The lock is open. Anyone can join the network. So all these are considered as nodes. And all these nodes are connected here if we observe. So one node can connect to any other node. But all these users are anonymous. So one user doesn't know the other user, but still they can connect. They can communicate. So open network, anyone can join here. And all the nodes have equal rights, no restriction on node operations. So all the nodes have equal operations. They can read the transaction, they can write the transaction, they can validate the transaction. So coming to the second blockchain, it is private blockchain. So the name itself, it is telling it is private. It is not open to everyone. The network is not open to everyone, and it is controlled by few nodes in the organization. So generally this private blockchain, we can go for a private institutions or private organizations. For example, if I want to design a blockchain for our college, I can go with a private blockchain. Why? Because some central persons will be there to monitor all these transactions, to validate all these transactions. So there we can go with a private blockchain. So it is not considered as a real blockchain as it almost follows the centralized policy. So we know why we are going with the blockchain. We have a problem with the centralized policy. So in the centralized policy, so one has the highest authority and he needs to take or he needs to validate each and every transaction. And he only maintains the data. So if there is any problem with this data, the data will be lost. That is called as a single point of failure. That is a problem with this existing system. So that's why we came up with a new technique called blockchain, which is decentralized and distributed. But here also, if we are following the same centralized technique and centralized policy for data storage, then it becomes the same as a older technique. So that's why it is not generally considered as a real blockchain. The private blockchain is generally not considered as a real blockchain. Why? Because some central authority will be there to monitor this. So coming to the key features, it is not open to the public, as we know, and all participants are pre-approved by the organization. So if I want to join the organization or if I want to join the network, I need to follow some steps, or I need to have some phenomena for that. and the owner or the central authority controls the permission to read, write or audit the lecture. So I will be the owner, so some person will be the owner, and we have some set of notes. So for all the notes, I can't give all the permissions, right? For example, the principal is there. So principal will give some set of permissions to the faculty and some set of permissions to the students. But I cannot directly give all the permissions to all the persons. So these are all some faculty, these are all some students. So faculty can enter the student data. I mean, the faculty can enter student marks. So this faculty may have some edit permissions, like write permissions. So they can write the marks. But the students doesn't have that write permission. They can't write their own marks, right? They have only the read permissions. So like that, the central authority will decide the permissions of all the users. So what operations they can do, whether they can write the transaction or whether they can read the transaction or whether they can validate the transaction. And the central authority controls the consensus mechanism. So the final decision will be taken by the central authority only. So if it is a public blockchain, we are taking some voting mechanism, the majority or agreement among the people, which we are calling as a consensus. But here the central authority will take the decision. And again, high cryptography methods secure the data. Again, in the blockchain, the data will be stored in the form of cryptographically. The encrypted data will be stored. And high transaction speed taking only seconds to create a block. So here I don't need to take a permission from other nodes, whether this block is correct or not. Here only the central person is validating the transaction, so it will take less time to create a block. And very low energy consumption. So in the public blockchain, just because of that proof of work consensus mechanism, it is taking more power consumption or more resource consumption. But here we are not using that proof of work. Simply the central authority will take the decision. So that's why it is taking low energy consumptions. But coming to the limitations, they are not decentralized. As we know, a central authority will monitor this blockchain. So it is not decentralized. It is not really called as a real blockchain. So blockchain is supposed to work in trustless environment. So one more feature of blockchain is trustless environment. So we are working with a person. On that person, we don't have any trust, right? We are working with anonymous people in the blockchain. So that is the trustless environment. But if it is a private blockchain, all the people we know, right? In the trusted environment, you're going to work. So it is entirely opposite feature of the blockchain. So if nodes are trusted, it may be cheaper to go with the traditional database. So instead of using this private blockchain, we can go with the traditional centralized database where it is taking less transaction cost. And a central authority means obviously it will be a single point of failure. So the central authority is going to maintain the data. The data will not be distributed among the nodes. I mean, among the nodes in the sense, if say maybe some of the people will maintain the nodes, not a single person, but still we have a single point of failure here. So this diagram indicates the private blockchain. It is locked. That means everyone cannot join here. So whoever knows the lock or the password of this lock, then only they can join the network. So access is permitted to only nodes within the company. So whoever within the company, then only they have that access to the network. And restriction on node operations as per the company protocols. So what are the company protocols are there? As per that, they need to follow the instructions. So whether I can create a block, whether I can validate a block, whether I can write into the block, whether I can read the block. So all these operations restrictions will be provided by the central authority. And coming to the third type of blockchain is consortium blockchain. So it is also called as federated blockchain. So it is a permission blockchain and considered be a hybrid between public and private blockchain. Hybrid in the sense some of the features you are taking from the private blockchain and some of the features we are taking from the private blockchain. But still it is permission blockchain. Permission in the sense some central authority will be there to control or to monitor the transaction. So the difference between the private and the consortium is, in the private we have especially one central authority will be there to monitor the transaction. But in the consortium, a group of companies form as consortium and they will be the central person here. So for example, only for MLR IT, if I create a blockchain, I can consider it as a private blockchain. I want to create a blockchain for the cluster colleges like MLR IT, MLR ITM and IAR. For these three colleges, I want to create a blockchain, a combinedly. Then I can go with the consortium blockchain. So here if I create this private blockchain, only the MLRIT people, the principal of MLRIT will monitor this. But if I create a consortium blockchain for all these colleges, so one person will be the MLRIT principal, one person will be the MLR ITM principal, and one more person will be the IART principal. So these are the set of central authorities will be there. But here we have only one central authority, whereas in consortium, multiple central authorities will be there. But still it is permission only. So unlike private blockchain, consensus mechanism is not controlled by one company, but by a predetermined consortium of companies. So previously we are taking the permission only from the principal, sir. But if it is a consortium, that information will be goes to all these principals, all these authorized persons. So coming to the key features of consortium blockchain are any member node initiate and receive transaction. However, the permission to write and audit the ledger is determined by the group of pre-approved individuals. So anyone can, initiate or the receive transaction. So it's like a public, the feature of public, anyone can see that. But who can write or who can initiate the transaction? Not initiate. Who can audit the ledger? Who can approve the ledger? That will be decided by the pre-approved individuals. For example, if I want to take a leave, I need to take permission only from the principal set, from MLRIT principal set. But here, if it is a consortium blockchain, that request will go to all the three principals, right? So here they will decide. So initially they will decide. So this request is coming from which college? This should be addressed by which principal? Like that, they will set their own rules initially before creating the blockchain. So the consensus process is done by a group of predetermined nodes that have full access to the ledger. So who have full access to the ledger in consortium network? Only this predetermined group of entities. So remaining all are not have all the permissions. They have only limited permissions. So for this people, I am giving this permission. For this people, I am giving these permissions, like that they will set. But only the central people will have all the permissions and they will decide. They will decide which transaction is valid or which transaction is not valid. And again, high cryptographic methods to secure the data. So again, the data will be stored in terms of cryptographic data. That means encrypted data will be stored inside a blockchain. So they are faster with higher scalability as compared to public blockchain. So the scalability is more here when compared with the public blockchain. And they have better transaction privacy and traceability. Obviously, if it is a semi-private, I can call it as a semi-public or semi-private. Why? Because the data is more secure when compared with the previous one. Of course, the data is secure in the blockchain itself, but here we are maintaining the privacy of the user. So coming to the challenges faced by this consortium blockchain are, they are not fully decentralized. Again, the problem same as the private blockchain. In the private blockchain, it is not fully decentralized, right? So one central authority will be there to monitor the transaction. Again, here also it's not fully decentralized. So we don't have a single central authority, but we have some set of central authorities to monitor the transaction, which made the blockchain as a permissioned blockchain. And different organizations have different requirements. This is the problem. So if I want to create a consortium blockchain, generically, I cannot create. So for specific characteristics or for specific specifications, I need to create, right? So if I am going with the engineering colleges, for these three engineering colleges, I need to create one. The same thing should be needed by some set of companies, IT companies. For them, the specifications may be different, right? So again, they need to rewrite the code. The code will be similar, but again, they need to create a new application for that. So examples are R2Coda and Hyperledger Fabric. So this diagram indicates a consortium. It is permissions. That's why it is showing a logged picture, right? So restricted access to a consortium. So if I observe here, so here we have two different types of nodes. This is one type of node and this is another type of node. So here this diagram indicates what? Validations by predetermined group of companies. So these diagram indicates what? Companies, pre-authorized companies. And remaining all these are some users, normal users. So these are all companies, 4 companies are there, 4 determined companies are there to authorize these remaining users. So the last blockchain is a hybrid blockchain, which is a more efficient blockchain presently we are using. So hybrid is nothing but just like combination of different blockchains. So here we are mixing the features of public blockchain and private blockchain. So we know we have some advantages, some better features in public blockchain, as well as in some positive features in private blockchain. Just we are taking the positive features of both the blockchains and we are mixing up and we are creating a new blockchain called hybrid blockchain. So what public blockchain provides? It is fully decentralized, tamper-proof, anonymous, transparent, immutable, and open to public. So these are all the features, positive features of public blockchain. Coming to the private blockchain, higher speed, lower cost, better scalability. Even if it is centralized, these are all the features of private blockchain. So I'm just mixing all these features into one blockchain, which makes hybrid blockchain. The hybrid blockchain, as the name suggests, incorporates the best practices of both the models, that is public as well as private. It takes the benefits of both the private and public blockchains, thus attempting to neutralize the negatives. So whatever the negatives are there, whatever the disadvantages are there, that will be overcome in the hybrid blockchain. Coming to the features, it is open to the public as it is following the public blockchain feature. It is open, anyone can join the network. The ledger is distributed within the network of participants. So every node will have maintain a copy of ledger. The private network creates hash of the transaction and passes on to the public network for validation and approval. So who is going to create the block here? The private network only. But who is going to validate that? The public network. So the public network is using the consensus mechanism called DPoS, Delegated Proof of Stake. So this we discussed in the previous video. The consensus mechanism, proof of stake in the sense I should stake some amount initially to participate in the consensus mechanism. If it is a delegated proof of stake, so instead of staking some amount, I need to get some votes. So based on the voting, the leader, just like a leader, will be selected and that person is going to validate the transaction. And coming to the private blockchain, it can use its own consensus mechanism. Generally, it will take its own decision. They don't follow in a specific consensus mechanism. So if it is a private environment, we are using DPoS, whereas in the public environment, we are using DPoS. Whereas in the private environment, based on the user's choice, they can use any consensus mechanism. So data is immutable and secured by high cryptographic methods. We know data is immutable in any blockchain. So once if I write into the block, that is not modified. That cannot be modified. I cannot modify that data. And here also it is using high cryptographic methods to secure the data. And it has the highest transaction speed. So the transactions created per second is more in hybrid blockchain when compared with all other blockchains. And practically hack proof, there is no malicious, as no malicious actor can either enter into the private network or public network. So they cannot enter either of these networks. So whatever the positive points are there in the public as well as private, they have meshed and they have created a blockchain called hybrid blockchain. But coming to the problem is, we have only one application in this hybrid mechanism, that is Zinfin. It is working under hybrid platform. So we don't have much resources on this. We have only limited applications in this. That itself is the problem with it. So the example is Zinfin. So it is open, right? So it is not closed. Anyone can join the network. So the key is also available here. So it's like I'm giving the key to everyone. So it is locked, but I'm giving the key to everyone. So the private network nodes, so some of the nodes are private network nodes and some of the nodes are public network. So it is just mixed. So who is going to initiate the transaction? The private network is going to initiate the transaction, and the further processing, the remaining adding transactions or validating the transaction, all these things will be done by the public network. So that's about the types of blockchain. In this video, we discussed about different types of blockchain like public, private, consortium and hybrid blockchains along with these features and limitations.